Let's start with a basic physical scenario. Say you walk into a store and buy 5 pens for a total of 60 rupees. To find one pen's cost, assign X to represent that price. With identical items, we multiply, creating the equation 5x equals 60. To find the unit value, divide both sides by 5, giving our final answer, x equals 12. You might have been able to figure out that answer in your head without writing out 5x equals 60. However, establishing the equation first is a mandatory habit for solving complex problems where the answer isn't immediately obvious. This translation pattern works just as well for intangible services, like digital data, as it does for physical goods. Imagine a user buys a 10 gigabyte mobile data recharge and pays 200 rupees. We want the cost per gigabyte, which is our new x. The translation is identical. 10x equals 200. The underlying structure remains the same. The total quantity multiplied by the unit cost always equals the total price. To isolate x, we perform the same mathematical action as before. We divide both sides by 10. 200 divided by 10 leaves us with 20 rupees per gigabyte. Algebra focuses on the relationship between these numbers. Whether you are buying plastic pens or invisible megabytes, the logic of the equation stays the same. We can apply this a third time by looking at physical distance and travel fares. A taxi travels 15 kilometers and the passenger pays 300 rupees. We need to find the rate per kilometer, x. Pause the video right here, write down the equation, and try to solve it yourself. If you followed the translation pattern, your equation should look like this: 15x equals 300. To isolate x, divide 300 by 15. That leaves you with a final rate of 20 rupees per kilometer. Repeating this 3-step structure, identifying variables, writing the equation, and isolating x, builds the muscle memory needed to handle any rate-based word problem. We can distill these examples into a formal rule checklist. 1. Convert your words into an equation. 2. Use multiplication when a total is given. 3. Use division to find the unit value. And 4. Check your final answer logically. These operations play distinct roles. Multiplication builds the equation to represent the total, while division breaks that total down to find the individual unit value. The logical check is a critical final step. If you accidentally multiplied 300 by 15 for the taxi fare, you'd get 4,500 rupees per kilometer, a result that immediately signals an error in your setup. For your homework, consider this problem. A number increased by 12 becomes 40. Find the number. Pay close attention to the phrase increased by, as it signals a different operation than the ones we use today. Using these algebraic translation rules bridges the gap between isolated math drills and real-world problems. Once you have mastered these basics, you'll be ready to solve equations with variables on both sides. Thank you for learning with Math Novas. Subscribe for more easy-to-understand mathematics lessons and continue your journey from basic math to advanced mathematics.